All right, next up we have the harder of the three arithmetic problems involving fractions, and we're supposed to do it without a calculator, of course. And what makes adding fractions so much more challenging than multiplying or dividing is the fact that you have to make the denominators the same. We've got 80ths, we've got 15ths. They have to be the same number of parts in order to be able to compare those things. The way we usually say it is that we have to have the least common denominator. If you think of these things as people, then these people need to be wearing the same kind of pants, like this picture here. So when we're adding or subtracting fractions, the denominators have to be the same. So I think all of these pants here probably came from the same exact place, probably the Gap. These khaki pants, they're all the same, and then we can combine these people together and notice that they don't have to be wearing the same shirt here. That's not important, but their pants have to be the same. I know this is a weird analogy, but just go with it. Okay, now then, kind of like we did with the multiplying and the dividing, I'm going to dive a little deeper into why these pants have to be the same. Let's look at a visual representation of some fractions, which you may have done back in the sixth grade. So one way, actually prior to that, when we were talking about fractions to begin with, this part over this whole, one way to represent that is with a pie diagram. Here we have some delicious cherry pie. You can see I have one of three total parts, and here for this neon blueberry pie, we've got one of four total parts, right? Very easy way to represent those fractions to get a kind of a visual understanding of how big each one of these things is supposed to be. So one way to combine these two fractions, of course, is just to maybe trace off this guy right there and then just put it right next to the cherry pie to make this combination blueberry cherry pie. That actually sounds pretty good. Anyway, so I can easily do that here. Let's see. I'll just take this little piece right here. You can see that's still 1/4 of the same size pie. I don't want to put it right there. No, I got to put it in such a way that I can easily combine this up. So I got to rotate this so that these things match up. It's easy to say, harder to do. Oh my God, it's like perfect. There we go. So now when you look at this, can you easily tell what size of pie that I have left over? Most of us can't look at that and go, yeah, I'm pretty sure that's 7/12. Yeah, it's probably not going to happen. But the 12ths there, that's the clue. What we need to do is try to get it to be the same number of parts that each of these pies are broken up to. And that's the common denominator. Between 3 and 4, the common denominator is 12. And I can get that pretty easily by just multiplying these two denominators together, like the 3 times 4 gives me 12. So if I break these pies up into 12 slices, it's going to be a lot easier to combine them up. So on the first fraction, 1/3, in order to get 12ths on the bottom, I'm obviously going to have to multiply this by 4. But if I multiply the bottom by 4, I'll need to multiply the top by 4 also. And ooh, look at that. 4 divided by 4. That's our fancy 1. If we multiply this now, I get the new fraction 4/12. Top times top and bottom times bottom. What's the difference between 4/12 and 1/3? Well, essentially it's the same fraction, right? I've just broken it up into 12ths instead of into thirds. And I'm going to update my diagram like this, delete all that stuff out. Well, okay, there we go. And now you can see that we've got 1, 2, 3, 4, 4 out of 12 total parts, but it's the same amount of pie, cherry pie. Okay, you haven't gotten shortchanged or anything like that. Maybe there's still some on the knife. You may have to lick it off or something. Whatever. Okay, so now let's look at the 1/4. On the 1/4, I'm going to break that up into 12ths as well. In order to get 4 to be a 12, obviously, we'll have to multiply this by a 3. If you multiply the bottom by 3, got to multiply the top by 3. There's our fancy 1. Multiplying these fractions gives me 3 out of 12. So 3/12 and 1/4, obviously they are the same exact fraction. However, it's just been scaled up so that I can easily compare it to the other fraction. And let me update the picture right here, delete, there we go. And we can see we've got 1, 2, 3 out of 12 total parts. And now that they're in 12s, it's easier to combine these things up. If I were to take this blueberry pie and put it right next to the um, the cherry pie, what I would have is putting 1, 2, 3 of these parts together with the 4 that I already had for a total of 7 12s. And that's what the picture is. That's right over here. There we go. 7 12s, right? Now, you don't want to have to do this every single time that you add fractions, but what it does, it gives us a rigorous understanding of why it is that we're supposed to get the bottoms to be the same in order to add or subtract fractions. Now, when it comes to the details of finding the common denominator, when they're numbers like 3 and 4, that's super easy. But what if there's something like these? I've got 8 over 15 and 11 over 21. Do I want to do the exact same thing that I did in the previous exercise, which was just like multiply the 3 times the 4? I could. You can multiply this 15 times 21 to get 315 as a common denominator, but it won't necessarily be the least common denominator. Now, just to be clear, you can still add and subtract fractions if you don't have the least common denominator. It just means that in the end, you will have to reduce your fraction a little bit more, and your problem might be a little bit harder just simply because your numbers are going to be larger. And remember, our goal here is to be able to do these things without a calculator. So what would you do in order to find the common denominator between 15 and 21? Well, most people, where they start is they take a look at the larger of the two numbers, 21 in this case, and you check to see, hey, does 15, the smaller of the two numbers, go evenly into 21? Does it divide with no remainder? And this one obviously does not. If it did, oh my gosh, your job is that much easier to do, but this one doesn't. So then the next phase in the process is taking that larger number, and then you can start taking multiples. You're taking multiples to find the smallest one of those multiples of 21 that 15 divides evenly into. It would look sort of like this. I would have 21 times 1, which is 21, but we already know that 15 doesn't go into that one, so that one's garbage. Okay, so then I would do 21 times 2. That would be a 42. Does 15 go into 42? I'm sorry, it sure doesn't. All right, and then you just keep going. 21 times 3, and you would get 63. Surely there's a more efficient way of doing this. Now, when your numbers are small, then this is not too bad. But when numbers start getting large, without a calculator, this might be pretty tedious to do. 21 times 4, I would have, let's see, 84. 15's not going to go into that either. And I'm able to say that just because if it ends in a 5, then whenever I'm multiplying dividing, my number's got to end in a 5 too. All right, which brings us to, say, 21 times 5, the fifth multiple, which would be 105. All right, so now we're in pretty good shape here because this one ends in a 5. I got a pretty good feeling that 15 is going to go into it, and it does. It goes like this. This is the same thing as 15 times. Let's see, I need to end in a 5. I'm going to try 7. So 15 times 7, you have 35, and 70, that works out. So 15 times 7 gets you 105. There's your least common denominator. So let's take a look at this problem in detail. 8 over 15 minus, let's just make sure, 11 over 21. And I'm going to scale up these fractions by their common denominators. This one, I need to make 15 into 105, and I can see that I'm going to multiply that thing by a 7. But it's got to be a fancy one, so it's a 7 over 7. And then the 21 needs to be multiplied times 5. Again, it was the fifth multiple here. So its fancy one is 5 over 5. And now multiplying these things straight across, 8 times 7, 56. And then our 105 that we talked about before, minus 5 times 11, 55 over 105. Now the pants are the same. We just subtract the shirts and we get 1 out of 105. All right, there we go. Check, check, check. Okay, now as far as finding a common denominator, this method will always work. It's a fallback plan if you're kind of stuck and you're not sure what to do. But I want to show you, pro tip, another way of finding common denominator, which might be a little bit more efficient than this. And it involves factoring your two numbers. So I'm going to write down my 15 and my 21, and I'm going to factor each one down to its prime numbers. So I got 15 is equal to, sure, 1 is in there, but we usually don't consider 1 to be neither prime nor composite, so don't worry about it. We got a 3 times a 5, and then the 21 is 3 times 7. And the strategy here is you're going to take all of the factors that you see with the most number of copies. What I mean by most number of copies is that sometimes you might get a factor here that's a 3 squared, and you would have to take 3 squared. But whatever it is they have in common, you don't have to take 2 of those copies. So you can see I've got a 3 in each one of those, but I'm only going to take one of them. That's a 3. And like I said, again, if there was a 3 squared here, I would take 3 squared because I need, I'm going to essentially say that 9 has to go into my number, not just 3. But here, just 3 has to go into my number. Okay. My least common denominator also has to have a factor of 5 in it because the first one has a factor of 5. And then finally, my least common denominator has to have a factor of 7 in it because the bottom one does. And now whenever you multiply these together, 3 times 5 is 15 times the 7. That looks real familiar. There's our 105. Now, as a matter of fact, this second method here about factors, this is essentially what you're going to do on steroids, essentially, whenever you get into Algebra 2, because instead of them just being numbers, they're going to be algebraic expressions that you'll have to find the least common denominator between, and this factoring method is the way that you do it. So if we come back to our original problem here, with your denominators of 80 and 15, I'm going to encourage you to try that method. Find a common denominator by factoring 80 and 15, and then seeing what their common factors are to make a list of those factors to multiply together.